Hey, deep divers, are you ready to dive into something pretty cool?
I know I am.
Today we're looking at state machines,
Oh, yeah.
specifically a new way of creating them in Java.
Interesting.
Imagine taking like a super complex process,
Okay.
like a business workflow, or even like how an AI makes decisions,
Right.
and then breaking it all down into like these clear steps that you can actually program.
Mm-hmm.
That's what state machines can do, and that's what we're going to be diving into today.
I'm all ears.
So we'll be using an article from Stackademic to guide us.
Okay.
It's called Creating Distributed State Machines in Java, written by Yileng Yao, and it came out just last month.
Oh, very recent.
Yeah, so we're going to unlock the secrets of this innovative new library, see how it can like totally revolutionize the way we build software, especially, for these large distributed systems.
Now, I think some people might hear state machine and just
Yeah.
sort of tune out, but really,
Yeah, they can be.
they're like the unsung heroes behind so many apps we use every day.
Yeah, for sure.
They give you this really elegant way to model and automate
Yeah.
all sorts of processes.
Mhm.
Imagine it like a roadmap with different stops along the way.
Right.
Each stop is a state, and there are rules for how you move between them.
Okay.
Super useful for everything from controlling game logic
Yeah.
to, managing complex financial transactions.
Like what you're saying, yeah.
But here's the thing. Traditional state machine libraries haven't really kept up with the demands of,
Yeah.
modern systems.
Right, especially distributed systems.
Especially distributed systems.
And that's where this article comes in, right? It introduces this whole new library.
Mhm.
And I was really struck by the author's motivation for creating it.
Oh, how so?
Yao basically said, enough is enough
Uh-huh.
with these existing libraries,
Yeah.
especially for building distributed systems or like apps with AI.
Right. They just don't cut it.
Exactly. They're too complex, not flexible enough,
Mm-hmm.
and they're missing key features for today's challenge.
For sure.
So they went to build something better. This new library called InnoBridge State Machine, or ISM for short.
ISM.
And for those of you who like to get your hands dirty with code, there's a link to the GitHub repo right in the article, so you can follow along.
Oh, fantastic.
Yeah, I definitely recommend checking that out.
So Yao recognized this gap
Yeah,
and decided to fill it, which is amazing because building reliable distributed systems is
oh yeah.
not a trivial task.
No, not at all.
I have to think about, data consistency across multiple machines,
Right.
graceful handling of failures,
Mhm.
and scalability as your system grows.
I'd love.
So it's no wonder that the existing tools just,
Yeah, they weren't designed for that.
they fall short.
Okay, so let's get into like the nuts and bolts of ISM.
Okay,
The article talks about this state interface.
right.
Now, for those who aren't familiar with interfaces in Java, think of them like blueprints
Okay.
that classes have to follow.
Mhm.
So every single state in your system, whether it's like order received,
Right.
payment processed, or something very specific to your application,
Uh-huh.
is represented by a Java class that implements this state interface.
Okay.
And each state has an action function which defines what actually happens
Yeah.
when the system is in that specific state.
And you know what I really like about using Java function for these transitions is that
Oh, yeah,
it gives developers a lot of flexibility.
Yeah.
They can, include complex logic,
right?
calculations, even calls to external services within each state transition.
It opens up a lot of possibilities.
And it makes it easy to integrate with existing Java code.
That's always...
You're not starting from scratch.
Right, right.
Building on what you have.
Now, any good roadmap needs a starting point and an end.
Of course.
So that's where initial state and terminal state come in with ISM.
Makes sense.
And Yao gives this concrete example, the initial Hello World class.
Okay.
It might seem basic at first, but it shows how to set up transitions between these states.
Right. Using Java functions.
Exactly.
And that's where we start to see one of the really cool things about ISM.
What's that?
The ability to pass data between states.
Oh, so it's not just a static thing.
No, not at all.
Okay, explain that, because that's...
So in a real process,
Yeah.
information flows from one step to the next.
Mm.
You need to maintain context.
Mm-hmm.
And ISM allows for this.
So they're not just these isolated things.
Exactly.
Like
They
the
can
trap.
share information
Okay.
and react dynamically to what happened before.
This is really different from those older,
Yeah, much more advanced.
if this, then that type of state machine.
Rigid state machine.
Yeah, exactly.
This is much more dynamic.
Wait, so this input data can actually change the path that the state machine takes.
Absolutely.
That's incredible. What kind of possibilities does that open up?
Oh, so many. Let's say you're building a system to handle customer orders.
Okay.
You could have a state for a verified payment.
Mm-hmm.
Now, normally, this state would just check if the payment was successful.
All
So
right.
you have a simple yes or no.
Right.
Either the order goes through.
Or it gets flagged.
Exactly.
Okay.
But with ISM, you could pass in additional data to this state, like the customer's purchase history
Oh, wow.
or their loyalty status.
So this information could actually influence the decision-making.
Absolutely. For a longtime customer with a good history, you might offer a grace period for payment.
Okay.
As in, if there's a small issue,
Wow, that's really smart.
you can build this intelligence and adaptability into the system.
So we're not just talking about like a simple yes or no decision tree anymore.
No, it's much more sophisticated.
ISM allows for much more like nuanced behavior,
Exactly.
which is essential for really intelligent systems.
Right.
My mind is racing with all the potential applications for this.
Me too.
But I want to make sure we break down the different types of states within ISM.
Sure.
The article mentioned a few, and I'd like to learn more about them.
Okay, let's unpack that. So you have non-blocking transition state.
Okay.
For transitions that happen automatically, like if everything's in order, moving from order received to preparing shipment.
Okay.
And then you have blocking transition state for situations where you need to wait for something external.
Like a trigger?
Yes, like a payment confirmation from a third party.
Okay.
Before moving to the next state.
So like a dependency.
Exactly.
Got it.
And to illustrate this, Yao uses examples like non-blocking hello world and just plain hello world.
I really like those examples, especially how the input data,
Yeah,
which is represented as a JSON node,
right.
can actually change the behavior of the state machine.
Yeah.
It's like each state can look at the information and decide what action to take.
Or which state to transition to?
Yeah, there are so many possibilities there.
Absolutely. And that's just the beginning. ISM goes even deeper with the concept of child state.
Okay, wait, child states. I need an analogy here.
Sure.
Is it getting a little complex?
So think about planning a trip.
Okay.
You have the overall trip,
Right.
which is like the parent state machine.
Mm-hmm.
Then within that trip, you have individual legs.
Okay.
Like flights, train rides, hotel
The
stays.
subtrips.
Exactly. Each of those legs can be a child state machine
Oh.
with their own states and transitions.
And the parent state machine, like the overall trip,
Yes.
waits for each of the child state machines, those legs of the journey,
Right.
to finish before
Yeah.
moving on to the next one.
That's how it works.
Okay, that makes a lot of sense.
Yeah.
Yeah, so you could break down even the most complex processes into these smaller, more manageable pieces.
Exactly.
The child meal example in the article really made that clear for me.
Oh, yeah. Good example.
Like, the parent state machine for the entire meal waits for those child state machines, breakfast, lunch, and dinner, to finish before the meal's considered done. And the way data is passed back up from the child instances is really cool.
Yeah, it's very well designed.
It's so warm.
And this hierarchical structure,
Yes.
it's not just for neatness.
Right.
It's for building more robust systems.
Oh, yeah.
If one of those child state machines hits an error,
Yeah,
the parent state machine can handle it.
so the system can recover.
Exactly. Maybe retry the operation
Oh, that's smart.
or trigger a notification.
So we have this super flexible system for defining states, transitions, and even nesting them within each other. But we haven't talked about how it works in a distributed environment.
Good point.
The article mentions MongoDB and RabbitMQ,
Yes.
but I'm not sure everyone's familiar with those.
You're right. Let's explain those.
Yeah.
So for those who don't know, MongoDB is a database.
Okay.
That's great for storing data in a flexible format.
Uh-huh.
In ISM, it's used for persistence.
Persistence, meaning?
Meaning that the state of your state machine is saved, even if something unexpected happens.
Okay.
Like a server crash.
So it doesn't lose its place.
Exactly. This is crucial for reliable systems.
Right, especially if you're dealing with, like a complex business process or something.
Absolutely.
Okay, and what about RabbitMQ? What's its role?
RabbitMQ is a message broker.
Meaning?
Think of it as a post office for your application.
Okay.
Different parts of your system can send messages to each other through it.
Okay.
And this communication can be asynchronous.
Asynchronous meaning?
Meaning that one part of the system doesn't have to wait for another part to finish.
Oh, so they can work independently.
Exactly. This is great for building scalable and responsive applications.
Makes sense.
So in ISM, RabbitMQ allows different states to communicate without blocking each other.
Okay.
For example, a state that's waiting for some external input
Mm-hmm.
can subscribe to a specific queue in RabbitMQ.
Oh, yeah.
And then once the input arrives, it can transition to the next state.
So it's like a really well-coordinated team.
Yeah, I like that analogy.
Everyone knows their role.
Mm-hmm.
And they can work independently.
And efficiently.
Yeah, which is really important for scalability.
Absolutely, especially for systems that need to handle a large number of requests.
Okay, so we've covered a lot today. Limitations of the older state machine libraries.
Yes.
The core concepts of ISM, the power of data passing and child states,
Mm-hmm.
and how it uses distributed technologies like MongoDB and RabbitMQ.
Yes.
It's clear that ISM's a big deal,
Oh, absolutely.
but I'm excited to see how it all comes together in practice.
Well, get ready.
Oh, okay.
Because in the next part of our deep dive, we're going to get our hand dirty with ISM.
Oh, awesome.
We'll explore the demo repository,
Okay,
break down some real-world examples,
sounds good.
and maybe even try a few things ourselves.
That sounds like a plan. Stay tuned, listeners, because we're about to unlock the true power of ISM.
And discover how it can revolutionize the way you build software.
Exactly. We'll be back after a short break.
See you soon.
Wow, that was a lot to take in.
Right.
ISM's pretty amazing.
It is?
All those possibilities are so cool.
Yeah.
But now I'm wondering how we can actually use this to build real apps.
Oh, yeah.
Especially, those AI-powered systems that I was talking about.
Mm-hmm.
Those sounds like...
Game changers.
Yeah. So how do we get from theory to practice?
Well, speaking of AI, you brought up another article.
Right, the one about building AI chat agents with LLM tool and state machine.
Exactly. So let's see how that connects to ISM.
Okay, so for our listeners,
Yeah.
imagine you're making a customer service chatbot
Okay.
for like an online store.
Mm-hmm.
You want this chatbot to be super helpful
Right.
and really guide customers through questions and problems.
Endlessly.
Exactly. And with ISM, you can map out that whole conversation flow.
As a state machine.
Yes. So you could have states like greeting,
Mm-hmm.
product inquiry, order status, support request.
You got it.
Each one is like a key point in the interaction.
And these states wouldn't just be labels.
Right, they'd have their own logic and action.
Exactly.
So like in the product inquiry state,
Yeah.
the chatbot could use a natural language processing model
Uh-huh.
to understand the customer's question,
Uh-huh.
and then,
It could search the product database.
right, and
And
then
relevant
look
information.
up some products, maybe you'd make recommendations.
Exactly. Personalized ones based on their browsing history.
Okay, and what if the customer asks about their order status?
Easy. The chatbot transitions to the order status state.
Smoothly.
Yeah.
Okay, and then what?
It grabs the order details from the system.
Okay.
Checks for shipping updates.
Right, and then
Gives the customer a personalized update.
it's like a personal assistant
Yeah.
that knows exactly what you need.
Now, remember how we were talking about child state machines?
Oh yeah, that was a good one.
Well, this is where it gets really cool for chatbots.
How so?
Let's say within the support request state,
Okay.
you could have child state machines for different types of support issues.
Oh, I see.
Technical issues, billing questions, returns.
So instead of jumping into like a general support script,
Exactly.
it asks questions first
Right.
to figure out the specific problem.
And then transitions to the right child state machine.
Oh, so it guides them down the right path.
You got it. It's like a built-in decision tree,
That makes a lot of sense.
ensuring the customer gets the right solution quickly.
ISM gives you this hierarchical structure,
Mhm.
and that lets you create much more personalized interactions.
Exactly. It's not just reacting.
Right.
It's guiding.
Okay, but this goes beyond chatbots, right?
Oh, for sure.
I'm starting to see that.
What if we apply this to a recommendation engine?
Okay, like for a streaming service.
Exactly. We could model the user's whole journey through the platform as a state machine.
Interesting. So what kind of states would we have?
Well, things like browsing,
Okay.
watching content, rating items, searching
Mm-hmm. And the transitions.
could be triggered by the user or even time-based events.
So like if a user keeps rating horror movies highly,
Yeah,
the system could go into a horror fan state.
exactly, and start recommending more horror.
And like new releases too.
Mm-hmm.
And if they haven't used the platform for a while.
It could transition to a re-engaged state
And then the personalized email.
with recommendations based on their history.
Yeah.
The possibilities are endless.
This is amazing.
So ISM lets you use data from all sorts of places.
Okay.
User preferences, browsing history, ratings,
Right.
even external data like trending topics or what's happening in the world.
And you can use that data to create this like,
A dynamic experience.
yeah, that evolves with the user.
It's not just a static system.
That's so cool.
It's really powerful.
So we've talked about chatbots, personalized recommendations. What else can we do?
Workflow automation.
Okay, is that a good fit for this?
Oh yeah, it's perfect for state machines.
So like,
Imagine a system for processing loan applications.
okay.
You could use ISM to model the whole process from start to finish.
So what would the states be?
Application received, credit check, income verification,
Mhm.
underwriting, approval denial.
And each step is automated?
Yes.
Okay.
And each state would have its own rules and actions.
Right. So in the credit check state,
Uh-huh.
the system would pull the applicant's credit report automatically
Exactly.
and then use that
to decide the next step.
Right, so maybe it moves on to income verification if the score is good enough, or it flags it for manual review if it needs more checking.
Exactly. And some states, like underwriting,
Yeah.
would be blocking states,
Meaning?
waiting for a human underwriter to take a look.
Okay, so it still involves humans.
Yeah, in some cases.
But the point is, the whole process is clear and manageable.
Exactly.
Wow, so we're talking about automating entire business processes here.
Yeah.
This would not only make things more efficient, but it could also, like, reduce errors.
And ensure consistency.
Yeah, that's a big deal.
Huge.
I can see how ISM could really change the way companies work.
For sure.
But before we go too far down this rabbit hole,
Haha, yeah.
we need to talk about the elephant in the room.
Okay, what's that?
We've been talking about all the good things about ISM.
Right.
But are there any, like, limitations?
That's a good point. It's always important to see the full picture before you jump into any new technology.
Okay, so are there any drawbacks?
Well, like with any new technology, there might be a learning curve.
Especially for developers who haven't used state machines before?
Yeah, or distributed systems.
Okay, so what do you mean by learning curve?
Well, even though Yao has great documentation and examples, it still takes time to learn a new tool.
Right, to really master it.
Yeah, and to apply it to different situations.
Makes sense.
And another thing to think about
Okay.
is community support.
Like, how active is the community?
Exactly.
Are there resources available if you need help?
ISM seems to be gaining traction.
Okay.
But it's always good to do your research.
Yeah, a good community can make a big difference.
Absolutely.
Okay, anything else?
The one last thing to remember is that ISM is a great foundation for building distributed state machines.
Right.
But it doesn't solve every problem of distributed systems.
Right, so you still need to understand those principles.
Yes. Things like data consistency,
Right.
fault tolerance, and scalability.
It's a powerful tool, but it's not a magic solution.
Right. You still need good design.
So ISM is a great tool with the potential to change how we build apps, but it's important to use it carefully.
To understand the big picture.
Exactly, like with any technology.
Knowing both the benefits and the challenges is key.
All right, so we've explored the applications of ISM.
Yes.
From chatbots to recommendations, even workflow automation.
A lot of ground covered.
And we've talked about some of the limitations. But there's one more thing we need to address.
And that is
how to actually get started.
the practical side.
Exactly, putting it into practice.
Well, in the last part of our deep dive,
Yeah?
we're going to walk through the steps of setting up ISM.
Awesome.
We'll look at the demo repository.
Okay.
And maybe try a few simple examples ourselves.
Sounds good.
We'll give our listeners the tools they need to start their own journey with distributed state machines.
That's a great plan. Stay tuned, listeners, because we're going to wrap up our exploration of ISM.
This exciting new tool for building distributed state machines in Java.
Exactly. We'll be right back after a short break. Okay, deep divers, are you ready to get your hands dirty?
Let's go.
We've talked theory, explored the possibilities.
Right.
Now it's time to see ISM in action.
The fun part.
Remember that GitHub repo link from the Stackademic article?
Yeah.
That's our guide today. We're going to see how this library works in practice.
Zhao really put together a great demo repository.
Yeah, it's amazing.
It's perfect for anyone who wants to try out ISM.
Totally agree.
Clear examples, good documentation, all the features we've been talking about.
It's a playground for learning about state machines.
For sure.
So, first things first.
Okay.
We need to add the ISM dependency to our Java project.
Right, that's the first step.
Usually just a Maven or Gradle configuration.
Nothing too complicated.
Even if you're new to those tools.
Once you have that, you need to tell your app where to find the ISM class.
Okay, how do we do that?
You scan the package with your state machine definitions.
Like showing Spring where everything is.
Exactly. It's like registering the blueprints so Spring knows how to put everything together.
Got it. Like saying, hey, Spring, this is where the magic happens.
Exactly.
What's next?
If you want more control over your state machine instances, like stopping them, you can create a controller class.
Oh, and Yao has an example for that.
Yeah, in the demo repo.
Sweet. That's pretty straightforward.
Yeah,
right?
very simple.
So just a few lines of code. And we're ready to build our own distributed state machines.
That's the power of ISM.
You know, I was a little intimidated at first.
I get it.
But this seems pretty easy to understand.
It is.
Even for someone who's not a distributed systems expert.
That's the beauty of it.
ISM does a lot of the hard work for you.
Right, behind the scenes.
So you can focus on the logic of your state machines?
Exactly.
Okay, let's look at those examples in the repo.
Sure.
I'm really curious about the Hello World one.
Ah, yes, a classic.
Seems like a good place to start.
It is. It's like State Machine 101.
Okay.
It shows you the basics, defining states,
Okay.
setting up transitions, specifying actions.
And you can see how the data flows between states.
Right, and how the different types of states behave.
Like blocking and non-blocking.
Exactly.
And then there's the meal example,
Oh, yeah, that one's good.
which shows how to use child state machines.
That's a powerful concept.
It is. It's like a recipe with sub-recipes.
Aha, I like that analogy.
The main recipe waits for each sub-recipe to finish before the dish is done.
Perfect example of how a parent state waits for its child states.
And the cool thing is you can run these examples locally using Docker.
Oh, yeah, Docker is great.
For those who don't know, Docker's like a little virtual environment on your computer.
Right, you can run different software without messing up your system.
And Yai provides a Docker Compose file.
Super convenient.
It sets up everything you need, MongoDB, RabbitMQ.
With one command.
It's so easy.
And once you have those containers running, you can use tools like Swagger UI
Oh, that's cool.
to interact on your state machines.
So you can see everything working in real time.
Exactly. You can trigger transitions,
Okay.
send input data.
And see the results.
A great way to learn how ISM works.
So we've gone from problem to solution,
Mm-hmm.
from theory to practice.
Full circle.
We've explored ISM's core concepts,
Yes.
its applications, and even how to get started.
With the demo repository.
What's the key takeaway for our listeners?
Well, I think the biggest takeaway is that ISM opens up a whole world of possibilities.
Yeah, it's pretty groundbreaking.
It lets developers build intelligent systems
That can handle complex processing.
and adapt to changing situations.
And it's not just for experts. Anyone can use it.
That's what's so exciting about it.
And like I said, this is just the beginning.
Right.
The combination of state machines and AI is incredibly powerful
We're talking about systems that can learn and make decisions.
in ways we never thought possible before.
It's a really exciting time to be a developer.
So, dear listener, here's a challenge for you.
Okay.
What process in your work or life
Mhm.
could you model better with a state machine?
How could ISM and AI change the way you do things?
We encourage you to explore these ideas, try out ISM.
And share what you learn with the community.
You might just create the next big AI-powered system using ISM.
That's all for today's deep dive.
But the learning doesn't stop here.
Keep exploring
Keep experimenting.
and keep pushing the boundaries of what's possible
We'll be back soon with another deep dive.
into a fascinating new topic.
Until then, happy coding.